Hi, welcome to Fun Science with Rohini. This series is titled 8 Days of Elegant Science, and you must be wondering what is so elegant about science. It is the logic behind the experiments that is elegant, the logic that is beautiful. And this logic has led to various proofs of hypotheses that were existing centuries ago. One such experiment whose logic is very beautiful, though the results are not accurate, is the distance of the sun from the earth as measured by Aristarchus. Now, centuries ago, people only had lunar eclipses, phases of the moon, or shadows to prove the hypothesis that they thought about. And Aristotle did that, Eratosthenes did that, as we have already seen in the previous videos. And now we are going to see how Aristarchus used the shadows of the moon and his knowledge of the phases of the moon to calculate the distance to the sun from Earth. Now, Aristarchus noticed that exactly at half moon, that is when a person is standing on Earth and looking up at the moon, and the moon is half lit, half moon, the rays of the sun that are incident on the moon are in a straight line, and the triangle that is formed by the rays of the sun on the moon, the rays of the sun on the earth, and the distance between the earth and the moon is a right angle triangle. Exactly at half moon, the rays of the sun incident on the moon and the rays of the sun incident on earth form a right angle triangle, and that makes this angle 90 degrees. Now, Aristarchus thought that if he can calculate the angle sun, earth, moon, SEM, let us say, if he can calculate that angle, he will get the distance to the sun. Simple logic. And using the crude experiments or crude instruments of science that were available back then, he calculated this angle as 87 degrees. Now, in a right angle triangle, back then there was no trigonometry, only Euclidean geometry was available, and using Euclidean geometry, Aristarchus came up with a simple calculation to talk about the distance of the sun from the earth. And this angle is 90, and Aristarchus calculated this angle as 87 degrees. And he said that in a right angle triangle, cos theta, if we take this as theta, cos theta, that is cos 87, equals adjacent by hypotenuse. And the adjacent here is EM. EM is the distance from the earth to the moon, earth-moon distance. And the hypotenuse is earth-sun, ES. The hypotenuse is the distance from the earth to the sun, or ES. So he said that cos theta or cos 87 is EM, adjacent, by hypotenuse, ES, earth sun, earth moon. And if we take this calculation, then EM becomes ES cos 87. So if you want to know ES, it is EM into 1 by cos 87, and 1 by cos 87 is 1 by 0.05 or 20. So Aristarchus used this simple calculation. He did not come up with any numbers, he just came up with approximate distances between earth and sun, using the distance between earth and moon as a point of that's not a point of contact, obviously. It's a point of observation or point of calculation. Yeah, point of calculation, sorry. So Aristarchus, what he did was he used this calculation and said that ES, or the distance between Earth and Sun, is 20 times the distance of Earth and Moon. That is, ES is 20 times EM. And even if Sun is so far away, it appears small because it's very, very far away. And the appropriate calculations, the actual calculations of this angle is 89.85 odd, 89.85 some more. And that comes to approximately 384 times EM, the distance between the Earth and the Moon. So Aristarchus was way off when he said that Earth-Sun distance is just 20 times the Earth-Moon distance. He was way off the mark, but it is the logic that is so elegant in this experiment, and that logic has been used to calculate the actual distances as well. Thank you.